Hi, my name is Robert Hernandez, and I'm an engineer at Martincoit Networks. And today I'll be talking to you about building a better NATS, path-aware networking, and a message bus. So before we get started, I'd like for you to imagine operating your most critical distributed systems directly over a wide area network like the internet with improved resilience and lower risk. Wouldn't that be interesting? I wonder how we might achieve that. I think by the end of this conversation, you'll have a better idea of a new, different approach to making this possible. So let's get into it. So the agenda for today is we'll first touch on the message bus overview and the challenges of operating a message bus, SCION overview, then we'll go into a NATS overview, the porting of NATS to SCION, the results of that port, and next steps. So the message bus. So what is a message bus? Well, it's a piece of infrastructure that allows different systems to communicate via messages through a shared interface. As you can see on the right-hand side of the diagram, we have the message bus in white, and then we have 6 clients connected to that message bus. The nice thing about using a message bus is that it provides a common platform for messages, and it removes the need for applications and services to communicate with others directly via APIs, because they can just use the message bus to communicate. That message bus can provide authentication and authorization for different topics to publish onto the message bus, as well as some congestion control and prioritization for different types of messages. So what are the challenges of operating a message bus? Well, first and foremost, the diagram that I previously showed you isn't exactly the whole truth. There's actually many more pieces to the message bus, depending on what type of message bus you're using. I've laid out what a typical message bus might look like, where instead of just the message bus being just a common um, middleware here, it's actually comprised of many different components. In this case, 5 servers, if you look at the right-hand side of the diagram, each with links to one another. So each server has a link to every other server. And then there are clients that connect to the servers. You could imagine any number of clients connected to a number of servers. All of this creates for a pretty complex network topology and introduces some different risks that now we've got because we're depending so much on the network. And since we're depending on the network and we've got a distributed system, we kind of have to consider the CAP theorem. CAP stands for consistency, availability, partitioning, and partition tolerance. And since no distributed system is safe from network failures, we really have to embrace that we've got network partitioning that we're going to have to tolerate. And that leaves us with 2 options that we've got to choose between, because according to CAP, we cannot have all 3 of these things be true. We can only pick 2 of the 3 options. We've got consistency or availability to choose from. And this isn't exactly the whole truth, where you can actually get shades of consistency and availability depending on the different system constraints and data that you're dealing with. But nonetheless, we just need to keep this in mind that because we're operating over a network, we've got many different failure states that we don't necessarily control. And bugs can be introduced into the operation of the system that can cause it to fail in unknown ways and end up in unknown states that we're going to have to figure out how to deal with. This is just a fact of life of operating such a distributed system. In the network, we've also got to consider security. We've got challenges securing the control plane and the data plane. We've got different solutions for this, which can be introducing private networks, VPNs, public key infrastructure, symmetric keys for encryption. We've got whitelisting. There's also authentication and authorization to verify who the user is and what they might have access to. All of these things help improve the operation of this distributed system. IT downtime when operating a message bus or distributed system is just a fact of life. But I think it is helpful to be aware of some of the costs that can be incurred across organizations when this downtime does occur. 98% of organizations incur over $100K for just 1 hour of downtime. And a major downtime outage, something that's over 24 hours, is increasing to 30% as of 2021. A lot of this is due to the complexities of cloud adoption, hybrid cloud, the distributed architectures we're choosing to utilize, SaaS platforms. A lot of these things are making it harder to understand different failure domains and identify points of failure and build against and build resiliency around them. Downtime also costs a fair amount depending on which industry you're in. The breakdown here is of the top 5 industries and the cost average hourly for those industries, with brokerages being at the top, with almost costing $6.5 million per hour for downtime. Now, what goes hand in hand with downtime is risk. And you've got to look at what's the probability of some of these things actually happening to us. So taking a look at 3 common types of risk that we take while operating a system. We've got ransomware, which is becoming increasingly common. And you hear about businesses being attacked every day from ransomware. So it's no surprise that it's 71% probability year over year and increasing and totaling a risk profile of 3.42 million. Next we have link failure, which can be switch failure, a router failure, physical links, cables being cut, power outages, which is almost as high at 70% probability and totaling in at $1.75 million in risk. And last, we've got DDoS, which at 50K doesn't seem like a huge risk profile, but this is per incident, which there's nothing stopping different automated systems from attacking your network and causing multiple DDoS outages in a given year. What if we could make a network more secure and resilient? What would that look like? There are many ways to go about trying to achieve this, but I'm going to talk about a newer technique and one that you might not have heard of before. So let's talk about SCION. First, what is it? SCION is the first clean slate internet architecture designed to provide route control, failure isolation, and explicit trust information for end-to-end communication. It provides an alternative to an existing routing protocol, BGP. SCION's got some interesting capabilities. It's able to authenticate on the control plane, which helps with DDoS attacks. Thanks to anything on that control plane needing to be authenticated. It also provides some interesting stability characteristics by providing multipath networking capabilities so that in the case of a failure, we're able to fail over to another link almost seamlessly. And for each of those different paths that we have within the SCION network, we're able to provide clients with path-aware networking choices based on performance, so they can choose which paths they'd like to traverse based on different types of criteria like latency, bandwidth, hops, and things like that. The SCION topology. So we've got some maybe familiar view of a network topology with some additional information around it. So I think what we'll do is we'll first start with the colored area of both of these circles, which would indicate the isolation domain. And the isolation domain is basically just a common jurisdiction of trust. And what that means is it can be a nation boundary, it could be a federation of nations, but it's basically a a boundary of things that you trust. So you have like the Swiss ISD and things like that. Then we've got the TRC, which is indicated by the little box at the top of both of these circles, which is the trust root configuration. Then the trust root configuration is a signed collection of certificates related to an ISD. So everything in this ISD is going to utilize the TRC. And that's how we get those authenticated control plane messages to help with DDoS. And then we've got the AS, and we'll start with just the normal ASs that are in white. Some of them are labeled with different letters, but those are just autonomous systems similar to other routing infrastructure, and those are just a common administrative controlled network. And then we've got the core ASs, which are a set of distinguished ASs and are responsible for the beaconing process. And that beaconing process is how we know what different paths we can traverse across SCION. The beaconing process is happening all the time to be able to check the health of different paths and basically be able to provide us all of this additional criteria so we know which links we'd like to traverse given our preferences. Now, within all of this, you can see that we've got an overlap between both ISDs 42 and 43. And C and D are overlapped. They seem to be in both. And this is totally possible within SCION. You can be part of any number of ISDs. And you can actually also peer in between ISDs, which is interesting. And that's indicated by the dotted lines, which is a way to short circuit network traffic without having to traverse the core. And you can see that we've got both your standard links going across ASs, and then you've got the peering links, and we've got two between B and C and Z and X. So how is all of this addressed? Well, SCION has its own address and different scheme. You might recognize some of the similarities with traditional IP network numbering, but it's actually got some additional fields. So we've got first the ISD, in this case 42, for our example, followed by a dash, and then the AS number, and then a comma, and then the host. Since in this case, we're actually leveraging loopback, which means we want to talk to this AS, you can actually put in different host addresses to talk to things behind an AS, should you need to do that. But just keep this address in mind as we go forward, because some of the examples I'm going to get into are specifically around dealing with this address. So what happens if we introduce SCION and a message bus? Well, we get NATS, NATS plus SCION, or SCION plus NATS. This is the porting of NATS to SCION, and the meat of what my 3-month research project entailed. So what is NATS? So NATS, short for the Neural Atomic Transport System, kind of a mouthful, is an established and distributed messaging system designed to provide streaming, key value, object store, and pub sub capabilities. Kind of does everything. There aren't a lot of missing capabilities if you're familiar with pub sub, KV stores, object stores, streaming. All of these things are within NATS. I have yet to find it lacking in a feature related to messaging. It started back in 2011, and then its current release is 2.10.7, and that was as of December 2023. So the way I landed at NATS, I didn't necessarily start out the research, was initially to look at just any message bus that would be appropriate to run on the SCION network. But I had this certain kind of criteria, and I was looking for projects that were active, and that meant within the last 6 months they had some type of development effort going on. I was looking for a project that was Go, because it would match the SCION PAN library, the path aware library, which is also written in Go, making it just easy to import, utilize. And then it would be nice if it had as little dependencies as possible, just so I didn't have to worry about any kind of dependency conflicts. So I'm going to be introducing a new library. Just different headaches that you might get with maybe a more um, a larger dependency tree. And then I'd like the code base, to be comprehensive, straightforward, since I'm going to be ripping out the network uh, layer. Um, that's hoping that whatever code base I chose had the appropriate abstractions and had thought about how they utilized the network and made that as straightforward as possible. The nice thing was that NATS was that project. It really fit the bill very nicely. The licensing is under Apache 2, so it's appropriate for me to pick up and go modify. Just some quick cons. Not I don't think anything was going to be without a couple of cons for me to pick up, but I think this list is pretty understandable for a project like NATS. Um, TCP only makes sense for the type of communication NATS is doing, and it having multiple components, a client, a server, a cluster kind of seems common, but then you've got things like a supercluster, which is a cluster of clusters, and you've got leaf nodes, which are just something else entirely. But they're all part of the way that NATS operates. So just having to factor those things in while porting was just going to be something I was going to have to keep in mind going forward and as I went into this. So porting at a high level, I was hoping to take and leverage the PAN library for SCION connectivity. And I was able to do that. And I could also use the SCION Proto, the raw Go libraries. But PAN makes it a little easier. It's got a little bit more of the ergonomics, does the heavy lifting, and provides a nice compatibility with Go's Netcon portable interface, which was something that I could pretty much do a drop-in replacement within NATS, which I'll get into in a little bit. But it made it really nice and easy. And then just having to go update multiple components for networking, kind of be a given uh, for a system like this, a distributed system, which the message buses are almost always. So that was just gonna have to be accounted for as I was going forward. And then also the fact that the address is not a traditional IP address. So there's probably going to be some incompatibilities with URLs and different addresses that I might be utilizing and passing around the system. So I'm going to have to factor that in. So we'll start with the SCION NATS listener, which is the server side of things. SCION doesn't have an implementation of TCP, so we're going to have to do something else. And that something else was quick via UDP, which is a native SCION transport. And that provided a very approachable alternative and one that I was able to get the server and clustering listeners to support. And I've included a little snippet here so you have some idea of kind of what that looks like. So the real meat of it is line 5 here, where I'm just getting a quick listener from the PAN library. I'm giving it an address, a TLS config, and then kind of nulling out all the other fields I didn't really need to do anything with them. There would be more here. I just kind of commented it out and called it transform SCION address in TLS, just so that this example is kind of more straightforward for you to see kind of the main core pieces of what was needed to get the server and the listener going. And I'm just getting a single stream listener, so that anything I do it, we're only going to do single stream. We're not going to have multiple streams. I think that is something maybe I can do in the future, but for right now, we're just keeping it to a single stream listener. And I left the conditional on line 9, which is if it's not a SCION address, we'll just return the normal listener. So we still have that compatibility with traditional IP for the server. So next up was the SCION NATS client. This is the server-side client that I'm showing here in what I was able to do to port it over to a native SCION transport via QUIC. If you look at starting at line 4 here, I'm actually, since this is the client, I actually get to do a path selection. So I can set different preferences for my path, policy that I might have, depending on if I want to do hops, bandwidth, latency, some combination of those. I can do the path selection from the time that I'm establishing this connection to the server. So I just want to show that there's a little bit more to it than what I have here. I've just kind of rolled it all up into that comment again so that you understand just kind of some of the basics that you'll need if you were to try to do a type of port of a client of some kind. And then in line 5 and 6, I'm just going to go ahead and dial QUIC, and that's going to call out and establish a connection just like it would for TCP or something like that. And then all I'm doing is returning the stream, which returns the same interface that's compatible with the net connection that I need to provide everywhere else within NATS. And just a quick comment here on URL formatting. I kind of ran into this all throughout the port of NATS since various URLs are used across NATS configuration. I have a kind of just a little example or snippet here of on the left side, I have a NATS address or a NATS URL with a SCION address in the URL. And on the left side, it's not compatible with normal URL parsing. And on the right, it is. And you can see the difference is really only those angle brackets around the ISD, the AS, and the host part of the address. Now, that actually in the URL spec is compatible. So all you have to do is transform that SCION address into this compatible URL parsable format. And to do something like that, have this snippet here, which is just a regex that'll go ahead and break up each piece of this URL. And then we pass the important part of the match, which is the third part of the match, which is again the ISD, the AS, the host, and actually the port number all goes to this pan mangle SCION adder function, and then returns and does the appropriate calculation to make sure that we're putting the angle brackets in the right place if this actually is a valid SCION address. Typically, I'd do a little bit more error handling and checks. But just for this example, it's just kind of a bare bones, naive example, just to give you an idea of kind of what you would have to do too to handle some URL formatting. So the current state of the SCION NATS port using PAN is that I've got a NATS client, the NATS server clustering. All of those three components are working within the NATS ecosystem, which gives me enough to be able to run some test scenarios over a SCION network using, more than just a basic, say, client-server model. I can actually introduce server clustering, some messaging, some kind of, I think, a little bit more complex real-world scenarios to test from. And right now, I don't have any more components ported. That's kind of some follow-up and what I'll be doing next. I'll get into it toward the end of the deck here. And there is some kind of shortcomings with the URL portability, I guess, between the SCION address and the traditional, like, just IP address URL formatting. I got to go through and really kind of figure out exactly where things might be not being transformed like I thought they were. But for the most part, it works. And it's just one thing I want to call out. That's kind of the current state of where I got to after the 3 months of this research. And so the test scenario that I want to get into real quick, just to talk about kind of what I saw from this port. So I have the diagram and this little this simple ISD, which basically consists of 3 core ASs and 2 regular SCION ASs. And then we've got we've got a 2-node NATS cluster running on AS4 and AS5, along with the client on AS4, which is subscribing to the hello topic, and the publisher being on AS5, which is publishing to the same topic. So basically, I've got some traffic that's traversing over the SCION network, and we've also set a path preference, so that's hops. So make sure that AS4 and 5 are utilizing AS3 so that we can go ahead and simulate our AS failure and see how SCION handles that. So if we simulate the failure here on the left, which is downing AS3, just basically taking the service offline, the SCION services offline, we'll successfully see that we route through AS1 and AS2 when we want to do communication between AS4 and 5, which is great. The failover happened pretty much instantaneously. You can see that the connection detects the failure and then quickly establishes another route, and it does it so fast that the NATS messages aren't lost. So I'm sending a constant stream of messages, and nothing ends up getting dropped during this failure, which was really, really interesting. And then if we go to the second second test case, simulated failure, which is simulating the AS2 failure now. So I'm going to bring back AS3 up. And when I bring back AS3 up, we're still routing through AS1 and 2. And I don't know if that's a limitation of the way I've implemented the listener. So it's not going to reevaluate certain things, but it seems to be sticky. So once the AS3 failure happens and I bring AS3 back up, it stays with AS1 and 2. At least for the time I tested, I didn't see it detect that and fall back. So I simulated another failure of AS2 and saw it fall back to the AS3 route. And again, that was the same behavior, which was the failover was instant because the link that it was using or the path that it was using failed and no messages were lost, and the NATS traffic, the pub sub messages still traversed the network and were received on the other end like nothing had happened. So I still have to investigate exactly the why it doesn't fail back. Something that definitely needs more investigation. But the fact is that the link failover does happen very, very quickly, and that is something that was really one of the main things that I wanted to get out of seeing what this does with a application like NATS. So that was pretty cool. So what's next for NATS? So currently I'm maintaining a fork of upstream NATS. I think I'm going to probably have to do that for the foreseeable future. I, I, I think the best way to get it maybe into NATS would be to do a custom dialer, which the NATS server, I don't believe it supports it yet. But it has this concept in the NATS client called the custom dialer, and then that's like the ability to write pluggable components so that you can just write a custom dialer without having to go and directly modify the server code or the client code, depending on which custom dialer you're trying to implement. So that looks pretty promising. I'm gonna probably check that out and see how much effort that would be, and maybe that's the viable way to get a more native SCION, maybe long-term SCION functionality upstream. We'll see. And then it would be nice to have a NATS CLI client that's full-featured. Currently, the one I wrote is very, very basic, and it just publishes messages to a single topic and then subscribes to that topic. But there are better clients out there and ones that I can definitely see porting over to SCION and providing that capability so that we can do a lot more with without doing a whole rewrite of a client. And I think going in and getting the rest of the server capabilities incorporated into SCION, like the supercluster and the leaf node, that would be a worthwhile endeavor, since it would kind of round out the full featured set of what NATS can do. And then I think this is probably way down the line, just because it's probably going to have to be an architectural change to how NATS is structured, which would be multipath support for the NATS control and data planes. That's just kind of at this point that's a really cool idea. I don't really know a path forward on how to do that today, but just something I'm thinking about. And then as far as what's next for SCION, um, I think that we need some more ways to run SCION. Right now there's only a handful, not even a handful. I mean, there's only probably like 2 or 3 ways to do it. You've got the SCION Labs, which is probably the best way to get going, and I've included a link in the next slide if anyone's interested in firing up SCION Labs and getting a SCION node up and running on a test network. You can run a local Docker environment from the SCION Proto GitHub, which would be something that's also worth doing, maybe a little more involved. And then you can build it, from all the open source components and from scratch, which is getting better. And hopefully, I think, given maybe 2024, we'll have a couple of different ways to do that, um, versus just really the 3 ways we have today. And then getting I think a native SCION porting guide would be really cool. There are a lot of applications I think would really benefit from having SCION connectivity built into them. Nothing requires you to have to port your application to use SCION. You could use the SCION Internet Gateway, the SIG, as is known, to pass traffic from a non, let's just say just a traditional application over a SCION network, but you don't get any of the uh, path-aware end host client capabilities. Those are just kind of you're you know you're just handing that off to the SIG to deal with. So I think a native porting guide would be pretty cool, given some people's experiences on porting some apps, since there's seems to be more and more apps being ported, um, and references to them. So I think that would help kind of build up some momentum. And then the path-aware network library improvements, um, those are steadily coming, and there was a lot of improvements in the last couple of months while I was working on this. So I'm excited to see more of those things coming, and hopefully I can be a part of that. Um, so we'll see where that goes. So I've got some useful links here. Anyone is interested in checking out martincoit.net, that would be our website. Come check out what we're doing. Uh, we've got a bunch of exciting news and blog posts that we're posting about the things we're getting into with SCION and deploying it across different production workloads. We've got the SCION Association, so that's basically the nonprofit that is helping helping get adoption, doing various things with research, and providing that to the community. And SCION Lab, if you want to try out getting a SCION node up and running on a SCION network, that's probably your best bet. Very easy, leverages Vagrant, and you can be up and running in a matter of minutes. If you'd like to see any of the work that was done and I tested and talked about in this talk, the GitHub links to the Martincoit repos are there, and those are the forks of the NATS server code, the NATS client that is just a simple SCION client, and then this talk is actually in a repository as well under my user. And then we've got the NATS IO, the upstream NATS project, should you want to learn more about NATS. So feel free to reach out to us at martincoit.net/contact. And if anyone would like to reach out to me directly, you can reach me on LinkedIn or on Twitter. And I hope you have a great rest of your day, and thanks for watching. Take it easy. Bye.